Okay, time for week 4, AP Calc video. Hopefully the last new stuff we're going to learn before we get to review for the AP exam. But anyway, we're going to just continue our sort of look at the fundamental theorem of calculus and all its magical powers, because so far it doesn't seem like it's all that great. So recap slash reminder is what the first fundamental theorem of calculus is, or FTC part 1, which is that if g of x is some accumulator function defined from a to x for some f of t function dt, then the derivative of g of x is f of x, and that's FTC 1. So ultimately, what FTC 2 does for you is, or part 2, looks at this in like a totally different slash backwards way. So ultimately, what this is saying, or one way to look at this, is to say, oh, if g prime of x, sorry, the red marker is dead, but if g prime of x is f of x, that's like saying the derivative of g is f. The other way to look at that is to say that the antiderivative of f is g. That we could just like take the antiderivative of both of these things. And you know the antiderivative of g prime. It's just g. So the alternative way of looking at the FTC is to, instead of say that g, the derivative of g is f, it's to say the antiderivative of f is g. So what we're basically going to do is we're going to sort of take that. So this is like code for saying the antiderivative of f is g. Except that's sort of not right. We need to like modify this a touch. And here's my little modification. An antiderivative of f is g, because there are infinity different antiderivatives. That's where our plus c comes in when we were sort of studying antiderivatives. So g of x is just some antiderivative of f. We don't know because the antiderivative of things, the constant just doesn't matter. But an antiderivative of f is g. And then the other thing we want to say is we're going to let big F of x be another antiderivative of f. So g is some antiderivative of f, and big giant capital F is also an antiderivative of little f, which basically means the only thing that's different about these things is the plus c. So another way to write that is that g of x is going to be f of x plus some constant. But the only difference between these two functions, one antiderivative of a function and another antiderivative of a function, is the constant. So, I don't know, basically, let's just get to it. So, with that in mind, we can evaluate this function at a couple of values. One, you can find g of a. And g of a is the same thing as doing f of a plus some constant. But we also know that g of a, if g is that same accumulator function type thing, the other way to look at g of a is that it's the integral from a to a of f of t dt. So that means that's 0, because we're integrating from a to a, and that should be nothing. So far what we know is that g of a, aka f of a plus c, is equal to 0. So let's toss this in our sort of little bank of info. I'm going to sort of write this down to get some more room. But right now we know that g of a, aka f of a plus c, is equal to 0. Alternatively, we can also find g of some other number b. And g of b is going to be f of b plus some constant. Or, alternatively, based on our accumulator function definition, g of b winds up being the integral from a to b of f of t dt. So, that's the other thing we know. is that g of b is equal to f of b plus c, which is also equal to the integral from a to b of f of t dt. So let's wrap these two things up. G of b minus g of a should be equal to f of a plus c minus, f of b plus c minus f of a plus c, also known as if you sort of simplify these things, the c should cancel out. Those quantities are important. So g of b minus g of a is equal to f of b minus f of a. But we know some more stuff about these things. We know that g of a was 0, and we know g of b was this integral, so that means the integral from a to b of some function f minus 0 equals f of b minus f of a. Translation, that 0 kind of doesn't matter, so in grand conclusion, we get this fun little nugget. That the integral from a to b of some function f is just big F of b minus big F of a. That maybe doesn't look all that powerful, but let's kind of just remind ourselves what f was supposed to represent. F was supposed to represent some antiderivative of the function. So in code, the much more useful second fundamental theorem of calculus says the way you can integrate from a to b some function f of t dt is to find the antiderivative, plug in b, find the antiderivative, plug in a, subtract them, done. So that's pretty much it for FTC2. Let's see it in works, in use on the next little video where we'll actually have specific functions to deal with here.